بسم الله الرحمن الرحيم سبحانك لا علم لنا إلا ما علمتنا إنك أنت العليم الحكيم. Dear students, today we will discuss linear or sequential search, that how the linear or sequential search algorithm will works and how we can implement the linear or sequential search. Before this, we have already studied the insertion, deletion, updation and traversing operation on array. So today we will discuss the linear or sequential search. So how the linear or sequential search will work? Let's see. In linear or sequential search, first we have an array of n values and the item that we want to search. Okay, the item that we want to search. This item that we want to search will be compared with the first value of the array. If the value is found at the first location, a message will be displayed to the user that the item is found at first location. But if this item is not exist on the first location, then this item will be compared with the next location, the second location. If item is found, a message will be displayed to the user that item is found at the second location. But if the item is not found, again the item will be compared with the third location, the fourth location, the fifth location, till the end of the array n. N shows the size of the array that shows that how many numbers or how many values are there in the array. So this is the working of the linear or sequential search. How we can implement this, what is the procedure or the algorithm to implement the studied process. So in first step we set up flag LOC. LOC is the flag. From this LOC, this will work. This is used for two purposes. One purpose is this LOC will work just like a flag. And then another purpose, if the item is found, then this LOC will store the index of the array that at which location the item is found. So this LOC works two purposes. One purpose is just like a flag, that if the item is not found inside the linear search, then it will display a message that the LOC value is not changed and item is not found. But if the item is found, then this LOC will store index of the location or index of the array that at which location the item is found. Okay, so in first step we set a flag LOC with a value -1. At the second step we enter the value or the item that we want to search. Okay, so this is the item that we want to search. Input that item from the keyboard. At the third step, that is the actual process, that the item is compared with the first location, the second location, the third location and the fourth location. So for this purpose we need a for loop. We need a loop that will start from the first location and will go till the last location of the array, that is the n. So for this we assign the index I from 1 and this index will go till the end. This is the size of the array. Okay, inside this for loop we will compare the item with the value at that index from 1 to n. So again a single if statement can do this. If item is equal to, this is the comparison operator, not the assignment operator. Double equal sign is used. This means that this is the comparison operator, not the assignment operator like this LOC assign with a value -1. So if item is equal to the array of the value at ith location, this ARR shows the name of the array. This is the name of the array. So the value at ith location at this array, if this is equal to the item, it means that the item is found. Okay, so we will assign this index to the LOC, that is the variable which is used as a flag, as well as shows the location if the item is found. So, and again a message will be displayed to the user that the item is found at this location. But if the item doesn't exist at the first location, so what we will do? Again the index I will be incremented and the process will continue again. So the I value will be incremented, the index will be incremented, and now the second location value will be compared with the item, then the third location, then the fourth location, until the final location of the array. So again, if I is incremented, I will be incremented from 1 to 2. Again 2 is less than or equal to n, means this loop will go till the last value of the array. If item is equal to the second location of the array, then a message will be displayed that the item is found. But if the item is not found, again the ith location will be incremented, and this process will continue till the end of the array. So whenever item is found, a message will be displayed to the user, but if the item is not found, the index I will be incremented. Okay, so this is the actual working or actual process of the linear search, that how the linear search or sequential search works. But if the item is not found, we search the whole array and item doesn't exist, it means that the LOC value is not changed. The LOC values change when item is found. So if the item is not found, it means that the LOC that is assigned to -1, that value is not changed. So if the item is not found, then we want to display a message to the user. Then how we can do this? Again, we will check that whether the LOC value is changed inside the algorithm or not. So if LOC is equal to, compare this LOC with -1. If LOC that is assigned with a value -1 and it doesn't change during the program execution or during the algorithm, it means that -1 will be equal to -1. This will shows that the item is not found. Okay, a message will be displayed to the user, and this is the whole process for the linear search, okay, in one-dimensional array. So if we want to search, or we want to do the linear search in two-dimensional array, what is the process? Again the same process, but in one-dimensional array only a single for loop is used, but in two-dimensional array a nested loop will be used. Nested loops will be used. So in one-dimensional array, a single loop can do our purpose or achieve our goal, but in two-dimensional array, two loops must be used to search a specific value. Okay, so in the first step, when we want to do a linear search in two-dimensional array, we will assign a flag LOC to 0, and at the end this LOC will be checked that whether this LOC is changed during the procedure or during the algorithm or not. Okay, so in first step we assign the LOC to 0. Again, which element you want to search, so we will insert that element. And the actual linear search, that is the third step, we will do the actual linear search, and in two-dimensional, two loops can do or achieve this process. Okay, so in the outer loop, first the R, this shows the rows. The row index will be assigned from 1, and there are n rows and m columns. Okay, inside this for loop, second loop for loop is there, that is used for the column. So again column value will be assigned from 1, and these columns goes to m. The column values will start from 1 and will go till the m values. Okay, so inside this, again a single if statement can do our work. If the item that we want to search, if this item is equal to the r row and c column and r row, the value at r and c rows and column of the array, if this value is equal to the item, it means the item is found. at rth row and cth column. Okay, and the LOC that is used is a flag in one dimensional array. This LOC works two purposes. One is for the location and the other is just a flag. In two-dimensional array, this LOC just works like a flag, okay, that whether the item is found or not found. So if the first row and first column value is equal to the item, so a message will be displayed to the user that item is found. But if the item is not found, then again the column value will be incremented, and the first column second value the first row and second column value will be compared with the item. If the item is found, a message will be displayed, but if the item is not found, again the column value will be incremented and the first row and third column value will be compared with the item, and this process will continue till the m column. Okay, so from first row to first row first column, and this process will continue the first row till m column, that whether the item exists in the first row and first column, second column, third column up to mth column. Okay, then if the item is not found at the mth column, so the inner loop will be terminated and the r value, the row value will be incremented to 1. Again the second row process will start, that whether the item now the second row value will be compared with the item. So the second row, again r value is incremented to 2. Okay, so the inner loop again starts from 1, column will be start from 1. So second row first column, second row and second column, and this process will continue till the second row and n column. A single value will be compared, every value, each location value will be compared with the item there, whether the item is found or not, and the process will continue. Okay, and the inner loop will be terminated when the column values is incremented and the column values goes to m plus 1. Okay, m plus 1. But the outer loop will be terminated when the r value is equal to n plus 1. So when the r values becomes n plus 1, then the outer loop will also be terminated. Okay, and if inside this nested loop, if the item is found, the flag value will be set to 1. From 0 to the flag value LOC will change from 0 to 1. But if the item is not found, it means that the LOC value is not changed. Okay, so hope you understand the whole process. At the last step, we will compare that whether the LOC value change during the algorithm or not. If LOC is changed, it means its value will be changed from 0 to 1. But if not changed, it means that the LOC value remains the same. So 0 will be compared with the 0. It means that the item is not found, and a message will be displayed to the user that the item is not found. But if inside the nested for loop, if the item exists in the two-dimensional array, a message will be displayed to the user that the item is found at this row and this column. Hope you understand the process. In the next slide, we will see the actual implementation, that how the linear search works. So let's move to the next slide. This is the actual implementation. These are the header file, hash include iostream.h, hash include conio.h. In these header files, the actual implementation of the cr, cout, cn and getch are there inside these header file. Then the main function will be started. CLR SCR, this means that clear screen. So first the control will goes to this statement, clear screen, and the console screen will be cleared by this function. Then we assign an array of values 1 2 3 4 5 6 7 8 9 10 10 values. We declare an array A and assign the value to each and every location, 10 locations. Okay, I shows the index of the array, LOC. This shows this works just like a flag, as well as the location or the index. Okay, and the item that we want to search. Okay, cout, this message will be displayed to the user. The array contains the following elements for I equal to 1. This is just the traversing operation. For I equal to 1 to I less than 10, I plus plus, then display the whole elements of the array. And this is just a blank space that between the two values, the 9 and 6 display a single space. It means that when 9 is displayed, then a single space will be there, and then 6 will be displayed. If this space is not given, then the whole values 9 6 5 up to so on, the whole values will be displayed, and there will be no spaces between the values. Okay, cout end L, it means that end of the line, the control will goes to the next line. Then again the cout statement, enter a value for searching. So cn, console input, and assign or enter the item that you want to search. Okay, this is the actual implementation of the linear search. Okay, so first we will assign I for I equal to 1 to I less than 10. Why starting the index from the 0? Because in C++ the array first index of the array starts from 1. Okay, so the array 0th location shows that this is the first location. So in in C++ the array index starts from 0. Okay, so therefore we assign the for loop from index 0 to till 9. The 10th value shows that this is the outside of the array. From 0 to 9, it means these are the 10 values. Okay, and I plus plus, and this is the if statement. If item is equal to the value at ith location, from 0th location till 9th location, at any point if the item is found, then we assign that index to the location. I plus 1, y plus 1, I already told you that the array implementation in C++ starts from 0. Okay, therefore we assign plus 1 with the ith location, and this process will continue. This process we already discussed the whole process in the previous slide. When this for loop ends, it means that whether the LOC value will change or not. If the LOC value is not changed, it means that LOC that holds the value 0 will be compared with the 0. It means that the item is not found. But if inside this for loop, if the LOC value changed, then the LOC value will contain the location where the item is found. So a message will be displayed to the user that item found or the value found at location LOC. And get ch, this is the last statement. It means that get character from the user. Okay, this is the implementation. We will see the implementation, the actual implementation. We will run this program now. Okay, and the implementation of linear search in two-dimensional array, this is your homework. You will do the implementation of linear search in two-dimensional array by yourself. Okay, now let's move to the actual execution of this algorithm. So for this, we will start the turbo C Turbo C++, okay. Data structure project, okay. And this is the linear search that we discussed now. So this is the first statement, iostream.h, conio.h, main clear screen. This is the array and initialize the values. This is the index, loc is assigned with the value 0. This is the flag value item that you want to search. Cout, the array contains the element. This is the this is the traversing these statements, this first for loop. Then again, which item you want to search, enter the item for searching. And this is the actual this loop is the actual linear search. This shows the actual linear searching, okay. Let's execute the program. You can run directly by control F9. So control F9. The array A contains the following elements: 9, 6, 5. Again, single spaces is there between the 9 and 6, the 6 and 5, up to so on. Enter the item you want to search. I want to search the item 23. So when I click, let's see, found at location 4, 9, 6, 5 and 23. Okay, so the item is found at 4th location, and now the control is at get ch. Whenever I click a single key from the keyboard, then the control will goes from this main function. Okay, let's see that we want to search the 2. So again, let's see, control F9. The 2 is there at location 5 as well as at location 7. So I want to search the 2. This shows that the item is found at location 5. Now I want to display both the locations. Now what should I do? I will display this else inside the for loop. Okay, so if item is found, again I will display this statement that item that holds the value that we want to search is found at location I plus 1. Okay, I plus 1. If I didn't if I didn't include the plus 1, then let's see, an end L. Okay, now let's check control F9. 2 error, semicolon is missing. Okay, the semicolon, I put the semicolon, and now I want to search. Control F9. Now I want to search the value 2. So let's see. Okay, 2 is found at location 4 and 2 is found at location 6, and look at that, item is not found. Why this message is displayed? Because I didn't change the LOC value inside the loop. Okay, so let's change the LOC value inside the loop. So I checked, I remove the what is called the comments, single line comments. So now let's check. I want to search 2. 2 is found at location LOC. Why? Because I didn't place the curly braces, and it shows that this if statement terminate at this semicolon, at the first semicolon. The body of this if statement is the first semicolon, so therefore it shows that the item is found at location 0, 1, 2, 3 up to so on. For the whole process, this cout was outside this if statement. Now let's check control F9, and I want to search the 2. So 2 is found at location 4 and 2 is found at location 6. Now 9 is the 0th location, 6 is the first, 5 is at the second location, 23 is at the third location, and 2 is at the fourth location. So to remove this ambiguity, I want to place plus 1 with this I plus 1. So now check the result. I want to search 2. So 2 is found at location 5 and 2 is found at location 7. Okay, but if I want to search a value that is not exist inside this array, so let's see that what the implementation or what the program displays. So I want to search a value that is not exist in this array. So I want to search 10. 10 is not there in this one dimensional array, and let's see. Okay, the item is not found. This is the actual implementation. Hope you people understand. And the two-dimensional implementation of the two-dimensional array, searching in two-dimensional array, this is your homework. Okay, hope you people understand. Okay.